Do you listen me? Yes, okay, perfect. So, okay, funny but not so funny. We will see almost everything related to Unicode, thanks to pizza, obviously, because I love pizza. You like pizza? Okay. Yes, 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 yes. Okay, so already said. Okay, almost there. Ah no, next. Okay, I'm Tommaso, cat lover. This is my two cats. This is the link social. I am a software engineer at Roma Search, and surely not a UI designer. So all my slides are grayscaled. Sorry. So let's start with playing a game. I will ask you to raise your hand if you agreed with a sentence. So let's have a try. Okay, we have hands. Perfect. So next, this is pizza. Yes. Okay. This. Okay. This. Okay. And this. Unfortunately. So, what we did, we see an image and we understood if it represents a pizza or not. So, somehow, in our mind, a definition of pizza pop up in our mind. So, more or less, we are able to write a definition of pizza. And most of probably, our definition is shared and agreed. Correct? Are you sure? Well, well, well. Let's continue our game. So, someone extend the pizza idea. You know where I want to land. This, obviously. But also this, why not? Also this, marshmallow pizza. Obviously, no one cooked that, but it's just AA created by AA, fortunately for us. So, what happened? Our idea, our definition of pizza was limited by our experience. And with new experience, we extend our pizza, okay? So we want to define what a pizza is and what a pizza is not through new experience. And recently this is called cross-pollination. I mean, meet people, talk with people, studies, and so on. And in the history, gnoseology with a lot of philosophers say something about that. But we are not here for that, fortunately or unfortunately. But this is what happened almost with Unicode in the history. So the history of encoding starts almost like that. Because in 1963, ANSI, American National Standard Institute, published the first draft of ASCII, sorry for bad pronunciation. ASCII is a 7-bit encoding, so we have a range from 0 to 127 letters, numbers, call-like symbols. Is not the correct word, but just to understand together. And so we can understand how a computer can serialize and write, memorize, choose the best word you want, A, B, C, and so on, 1, 2, 3, 4, and so on. But in the standard of ASCII, 1 bit left, because we know the computer use 8-bit for a byte, not 7. So 1 bit is left unused. And what happened when the PC were sold? outside America? All non-English letters somewhere, has to be defined, represented in this. So, iski, viski, atashki, and arder, burn. What means the first 0 to the first part of the range, so the 0 from 127, keep the same standard, the ASCII, but the rest, so from 128 till 255, depends on the encoding. So, for example, the accented E could be represented in this, in 4 different ways. And obviously, happened, unfortunately, in 1984, this series that the first part of this series, because this series is actually 15 different variants, the first variance is Latin 1. So, again, another type of encoding. And this is completely a mess. No one understands what is encoding. There is no standard. Fortunately for us, UNESCO saved Naples-style pizza in 2010. Yes, the same did Unicode. Unicode in 1987, some people meet together and choose, hey, we need to decide what is a standard. So, based on ASCII, they define a new standard, the Unicode. Unicode formally is the Unicode standard because there is also the consortium that maintains it, but normally we refer with Unicode with the encoding. So, what is the Unicode? Unicode is just a merely text representation, and just list all the symbols and numerate them. So, the first is the null point. The 65 is the uppercase A, and so on. So, there is 1, 2, the first, the second, the third, the fourth, the fifth, and so on. So, it's just a list of symbols. It's not a encoding. In fact, the real encoding, Unicode define 3 encoding, actually define more than 3, UTF-8, UTF-16, and UTF-32. That is the normal encoding we use today, fortunately. Hi. So, but what is the UTF-8? Actually, formally, is a Unicode transformation format that enable us to represent a symbol in bytes. How? Using 4 different ways, from 1 byte up to 5 bytes, and this is not okay, but is okay, better than before, because at least it's a standard. So, for instance, we use just 1 byte for represented uppercase A, but we use 2 bytes for represent the accented E. That letter, I don't know, use 3 bytes, and the last one, the 4 bytes. So, as you can see, different symbols, actually called graphene, use different number of bytes. So, this is more like what a Unicode UTF-8 character is represented. So, as you can see, the parser, so because sooner or later we need to parse the byte to transform the byte from in the text, read the first bit bit of the first byte and say, hey, is it 0? Yes, so it's an ASCII. Is 1 followed by 1? Yes. So, and followed by 0, so means there is 2 bytes, and so on. This is how a parser understands how many bytes is expecting to decode a character. But return for a while back to a pizza. Because pizza, given a pizza, we know understand the ingredients, no? So, for example, this is the margherita, so pasta, obviously, tomatoes, basil, mozzarella, and oregano. Oregano is not a part of the real margherita. Anyway, so given an image, we understand which is the ingredients. It's true for UNIF8. So given a symbol, we know which bytes compose it. Well, funny but not so funny. The answer is no, because if we see a byte, characters, there is a different way to represent it in UTF-8. Let's make an example. For instance, you can encode, we will see before, the accent E. So we can use the 2 bytes representation. But there is also called modifier that is a UTF symbols that modify the previous one. What means if I put an E followed by this modifier, it becomes E accented. What? Yes. So there, in this case, the right encoding use 3 bytes. So given the E accented, we don't know which bytes represent it. Potentially there is these two representation. Obviously the first one is preferred because it uses less bytes. But could be an attack, an informatic attack using this, for example. Because you don't understand the URL, for example, the DNS, there is a lot of warning about the R, the O, and so on, because you copy the URL and inside the domain, if these kind of characters, the O, real O, ASCII O, is one stuff. There is some characters in UTF-8 that is similar to O, but is not O. So our eyes see O, but is not O. And we need to pay attention a lot in this case. So there are different symbols, but there is yes, difference, yeah, but the representation, what we see, is the same. But could be worse, because we can ask the pizza chef to merge 2 pizza. Hey, sorry, I have very, very hungry, so I would like to have 2 pizza in once. Could you put all the stuff in unique pizza? And the pizza chef, yes, we can do that. In UTF-8, we can do that thanks fully to zero-width joiner. That is another symbol, code points actually, that join, merge 2 symbols. So given 2 symbols, we can join together. For instance, the flag and the rainbow, say they make the rainbow flag. And how we can do that? Because we have the byte representation of the flag plus the representation of zeta zero with joiner plus the bytes of the rainbow. This is represented in this way. What? Yes, we can do that. So it's a completely mess. We started with ASCII. After that, a different variants of ASCII burns. Now we have Unicode, but in order to support every language, Unicode, we have this mess again. So, is easy? Absolutely not. Let's have a quick demo. I prepared a quick demo. This is the code available in the GIST GitHub. So if you want, you can run it. Is a Node.js code. It's not so difficult to read and to write. So, do you read? I can zoom it. Zoom, 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 zoom. Okay. Should be enough. So, this is the URL. But, okay. So, let's have a quick example. We have symbol. Our first introduction is, hey, UTF-8 doesn't use just 1 byte, 2 bytes, 3 bytes, or 4 bytes. Depends on the symbol. So this is some example. All ASCII characters, 7-bit, obviously, are represented just 1 byte, followed by E accented, or in this case, the copyright is used 2 bytes. The snowman, this is the snowman, use 3. This is the symbol of doctor, the snake around I don't know how to call it. The flag use 4 byte, rainbow, cat, and woman emoji. So, as you can see, this is just one graphene and code points. So, is represented uniquely in this way. And there is the, inside the table of Unicode, you can find them. So, again, we have the modifier. A modifier is accent, as we saw before, and the slash. Okay? Also, them are represented in Unicode using just 2 bytes, but it's not so important. How we can use them? In this way. So, we have the E, just the E, normal E. And if we follow the normal E with the accent, we found this way, this. But that is equal about this. This is what we talked about before. That the symbol, what we see, is represented in 2 ways, using just 2 characters or 3 characters. Obviously, we can add an accent to an accent E, and in this case, we found 2 accents here, using 4 bytes, and the E plus another modifier, in this case the slash, is represented in this way, so the E slashed. As you can see, these use 3, 4, and 3 bytes. So, this is just the concatenation of bytes. I concatenate just literally the bytes. So, the E is 0x65, followed by the accent 0xcc, 0xcc, and 0x81, 0x81. The same as below. So, there is other modifier. In this case, we see the 2 emoji. I call it, it's not a standard name, but a modifier that allow you to move, to represent a symbol in emoji style. For instance, this is the copyright and the snowman. If I concatenate these 2 with the emoji, but is not clear. I select it. It's not so better, but anyway, this is the as you can see, the sea is changed, but also anche the snowman is changed. So we can have a multiple modifier that allow us to modify our characters. Also, the E is quite the same, but it's not the same, and the cats remains the cats. Last but not least, I promise you the 0 with joiner. That is empty of the representation, but allow us to do something. For example, we already seen the rainbow flag, but we can create a doctor, the woman that make a doctor, but we cannot bring two random stuff and join together because it is not applied. Is not applied by this viewer because this is not standard. This is the viewer choice to represent these bytes, these 11 bytes in this way. If there is old screens that is not up to date, this could be also represented, concatenate literally these two graphene, these two representation. So the rainbow flag actually could be not represented correctly because it depends on the program itself, the browser, the shell, and so on. So, in the end, about this is what is the length about this? Well, we understood it is very, very complicated. It's very difficult. We know that the rainbow flag is the flag plus with 0 with joiner plus the rainbow. We understand that the emojid snowman is the same, more or less, so we can suppose that is actually the flag, the rainbow, the snowman, and because the snowman is emoji, is the 2 emoji modifier. So actually this is 4 plus, because it's 4, in every couple I need to put the 0 joined modifier, so other 3. So 7, so sorry, okay? So it could be 7, but depends on what you want to know, because the length is misleading. Is the length of the characters, is the length of the bytes, what is the length, depends on what you want. For example, if you want to choose the right size of a column inside the database, because this is the main topic here, or the length of the message at client side, you need to pay attention about this, because it's not so easy. So, actually, surprising or not surprising, this is the concatenation of what we said before, less the to join, because this is, I don't know why, but the terminal choose to represent the snowman directly into emoji way. So this is the representation using 17 bytes. But if I choose to select it, I can select just 2 bytes. As you can see, it's just 2 bytes, the rainbow flag and the snowman. So it's very, very difficult. So what we learn? UTF-8 use 1 up to 5 bytes for representing symbols. Oops, okay. Actually, that becomes the standard web. I hope all of you use UTF-8. or UTF-16, depends. Is generally a space saver. I mean, instead of using, for example, UTF-32, use always 32 bytes, to represent the bytes, to represent a characters. And this is obviously not a space saver, because even if you are using only ASCII, all the bytes are almost zero. And is the standard of the JSON, so if you want to return a JSON in your API, you can avoid the char set. So content type, application/JSON, you can avoid to put a semicolon char set UTF-8, because the standard of JSON is UTF-8. And obviously we understand that writing a parser of UTF-8 is not so easy. And this is why not everyone use UTF-8. The big impact is this. JavaScript engines use UTF-16 to represent strings. Below you can find the Node.js implementation, for example. Why? Well, the reason is for the simplicity, because UTF-16 is easy to parse than UTF-8. And well, I don't know how many of you use MySQL. Someone use MySQL? No one? Ooh. 8 or okay. So because it changed, the default was Latin Uno before the 8th version. Bad choice, but the Sweden, the north of Europe commonly used Latin 1. Now, fortunately, use the default UTF-8, multi-byte 4, please, not multi-byte 3, because these keep 4 bytes for every character, so you can write varchar, for example, or char 4, and this is for graphene, not 4 bytes, for example. And this is very, very useful. And well, thank you. Below there is a nice article of how Node.js, you can handle emoji in Node.js. Very, very useful if you want to go deeper in understanding, I don't know, blocks, scripts, code points, graphene, and so on. I choose to not go so deeper because otherwise it was not so funny, the talk, at least.
Thank you, Tommaso. A big round of applause. So, if you if you have any question, no one? Everybody slept during the talk, or is they think about the cat at the beginning? I think. No one? No questions? No. Which of the pizza you preferred before in the first slides? There is no pineapple pizza. I didn't see them. Oh my God. Pizza open. Marshmallows, yeah. Who want to eat the pizza with pineapple? Thanks God. No one.
My preferred one is marshmallow. That for...
Thank you to be here. Go away.
No, for generating that image, I took almost 1 hour because the EA doesn't understand what a pizza with marshmallow is, fortunately. So, it's a mess.
Oh, thanks God. Pizza with sushi is interesting, by the way, but I don't know. Thanks again, Tommaso. A big round of applause, please. Thanks.